On a warm evening in August 1920, a respected government physicist stood in front of a paying crowd at the Berlin Philharmonic Hall and helped put the most famous scientist in the world on trial. Ernst Gehrcke, a career experimentalist at Germany's National Physics Institute, had spent months organizing this event, and among the charges leveled that night was one word sharper than any of the others: plagiarism. The accusation was that Albert Einstein, celebrated across Europe as the man who had rewritten gravity itself, had quietly lifted a key result from an obscure school teacher who died before anyone thought to ask him about it. The question this story has to answer isn't whether Einstein was right about gravity that was already being confirmed by astronomers around the globe. The real question is what turns a careful, credentialed scientist, a man with real discoveries to his name, into someone who spends decades trying to take down the reputation of a colleague he never even had a serious argument with in a laboratory. Gehrcke was not a crank who wandered in off the street. Born in 1878, he trained as a physicist and built a solid, respected career at the Physikalische Technische Reichsanstalt in Berlin, Germany's premier institute for precision measurement. Think of it as the country's national standards laboratory, the kind of place where reputations were built one careful measurement at a time. Working alongside Otto Lummer, he co-developed what's still called the Lummer-Gehrcke interferometer, a clever plate device used to split and measure light with extraordinary precision, useful for spectroscopy and studies of atomic emission. He also did serious work on canal rays, an early form of what we'd now recognize as positive ion beams. Colleagues described him as meticulous, stubborn, and deeply committed to a very particular kind of physics you could see, touch, and visualize with mechanical models. He didn't trust abstraction for abstraction's sake. That temperament would matter enormously once Einstein's ideas started reshaping the field. Because what Einstein was proposing by the mid-1910s was, to a mind like Gehrcke's, almost offensively abstract, space and time bending. Gravity not as a force pulling objects together, but as the geometry of space-time itself, curving around mass. No little gears, no visible mechanism, just equations describing a universe that refused to look like anything you could build on a workbench. Gehrcke started raising objections as early as 1911, years before Einstein's general theory of relativity was even finished, on largely philosophical grounds. He argued relativity was unanschalich, not intuitively visualizable, and worried that physics was drifting away from anything an experimentalist could actually anchor to reality. At this stage, it wasn't personal, it wasn't about theft. It was a serious, if increasingly rigid, scientist pushing back against a style of physics he found untrustworthy. Then came November 1915, and everything got more complicated. For over half a century, astronomers had known about a small, stubborn anomaly in the orbit of Mercury. The planet's closest approach to the Sun, its perihelion, drifted slightly more than Newton's law of gravity said it should by about 43 arcseconds per century, a tiny wobble, but a real one, first flagged by the French astronomer Urbain Le Verrier in 1859. For decades, the leading explanation was that an undiscovered planet, nicknamed Vulcan, was tugging on Mercury from an orbit even closer to the Sun. Astronomers searched for it. They never found it. The anomaly just sat there, unexplained, an embarrassing loose thread in the otherwise magnificent tapestry of Newtonian mechanics. Then Einstein, working through the final version of general relativity in a burst of intense calculation in November 1915, found that his new field equations predicted exactly that leftover wobble, 43 arcseconds per century, with no extra planet and no adjustable parameters. It fell straight out of the geometry. This was, for many physicists, the first real proof that general relativity wasn't just an elegant mathematical toy. It explained something the old physics genuinely could not, and it did so precisely. It's worth pausing on that, because this triumph actually predates Einstein's global superstardom. The 1919 solar eclipse expedition, led by Arthur Eddington, is the moment most people remember when starlight bending around the Sun made front-page news everywhere. But inside physics, Mercury had already convinced many of the skeptics years earlier. Gehrcke went looking for a way to take that triumph apart, and he found one in the unlikeliest of places. Buried in the back issues of a mathematics and physics journal was a paper by Paul Gerber, a physics teacher at a gymnasium in the small Pomeranian town of Stargard, published in 1898 and reprinted in 1902. Gerber had proposed a modified law of gravitation, one that assumed gravitational influence traveled at a finite speed rather than acting instantaneously, and from this he derived a formula for Mercury's perihelion advance. Remarkably, his number also came out close to 43 arcseconds per century. Gehrcke was not a famous man. He published in relatively obscure venues, held no significant academic post, and died in 1909, 6 years before Einstein ever touched the problem, with essentially no one in the physics community paying attention to his work. He never lived to see it become a weapon. That's the detail worth sitting with for a moment, because it reframes the whole affair. The man supposedly plagiarized never accused anyone of anything. He wasn't in the room, wasn't consulted, and had no idea his forgotten formula would someday be waved in front of a packed auditorium as evidence against the most famous scientist alive. Every accusation that followed was made entirely in his name, by other people, for their own reasons. Gehrcke resurrected Gerber's paper in 1917, republishing it in the prestigious journal Annalen der Physik, the very journal where Einstein had published his own breakthrough papers, with a pointed preface asking readers to notice the striking numerical coincidence. It was framed carefully, almost cautiously, as a priority question: shouldn't Gehrcke get some credit? But caution didn't last. Over the next few years, as Einstein's fame exploded following the eclipse results, Gehrcke's rhetoric sharpened from a scholarly footnote into a public accusation of theft. The Escalation reached its peak on that August night in 1920 at the Berlin Philharmonic Hall, an event organized under the banner of the Study Group of German Natural Scientists for the Preservation of Pure Science. The public face of the group was a man named Paul Wayland, an engineer and political agitator with a talent for organizing crowds and, as later research revealed, a history of financial schemes and shifting allegiances that made him an odd champion for scientific purity. Tickets were sold. Pamphlets were handed out attacking relativity as unproven, dangerous nonsense being pushed on the German public, with Gerber's name invoked as proof that Einstein's most celebrated result wasn't even original. Gehrcke was the credible scientific face behind the spectacle, lending intellectual weight to what was, in large part, a piece of theater. And Einstein, by most contemporary accounts, was sitting right there in the audience. The details of that night have been retold slightly differently in different recollections written down afterward, so it's worth treating the finer points with some caution. But the broad outline is well documented. Einstein came with friends, reportedly found the proceedings absurd enough to laugh out loud at points, and left more amused than wounded, at least on the surface. 2 days later, on August 27, 1920, he made sure everyone knew exactly what he thought, publishing a scorching reply in the Berliner Tageblatt titled, with deliberate sarcasm, "My Answer on the Anti-Relativity Theory Limited." The title mocked the group as a kind of commercial enterprise, a company incorporated for the sole purpose of tearing down his work. He named names, calling out Gehrcke directly, and addressed the Gerber question head-on. He stated plainly that he had never seen Gerber's paper before completing his own calculation in 1915, and that even setting aside the question of who saw what, Gerber's derivations simply did not hold together. The formula produced the right number, but the physical reasoning behind it, according to Einstein, and independently according to other physicists, including Max von Laue, contained errors that made it internally inconsistent. You could not actually get that formula from Gerber's stated assumptions using valid mathematics. In plain terms, matching answers don't prove matching logic. A calculation that happens to land on the correct figure through a broken chain of reasoning isn't a scientific discovery waiting to be credited. It's a coincidence, or possibly a case of someone quietly working backward from the known answer to manufacture a formula that fit it. That distinction mattered enormously, and it's the crux of the whole dispute. Plagiarism isn't just about two people arriving at the same number. It requires evidence that one person actually saw, used, and passed off another person's specific reasoning as their own. Nobody produced a letter, a citation, a shared colleague, any documented pathway showing Einstein had ever encountered Gerber's paper. Gehrcke's case rested almost entirely on the coincidence itself, treated as proof by sheer implausibility, as if two people couldn't possibly land near the same number without one stealing from the other. But physics is full of independent near misses and coincidences that later collapse under scrutiny, and several of Gehrcke's own contemporaries said as much at the time. The mainstream physics community's reaction to all this tells you a lot about how seriously the accusation was actually taken inside the field, as opposed to in the press. Max Planck, Max von Laue and Arnold Sommerfeld, heavyweight figures whose opinions carried real institutional weight, largely treated Gehrcke's campaign as a personal fixation rather than a legitimate scientific dispute. Von Laue went so far as to publicly dismantle the mathematics behind Gerber's derivation. Yet the affair didn't simply evaporate because it had gained a much more dangerous ally. Philippe Lenard, a Nobel laureate for his work on cathode rays, back in 1905, a man with genuine scientific stature who nonetheless increasingly folded his opposition to relativity into a broader nationalist and eventually explicitly anti-Semitic framework. Where Gehrcke's objections stayed rooted, at least in his own telling, in epistemology and methodology, Lenard's hostility curdled into something uglier over the following decade, laying groundwork for what would later be branded Deutsche Physik, a movement that after the Nazis took power in 1933 tried to formally recast relativity as corrupted Jewish physics unworthy of German science. It's worth trying to understand what was actually driving Gehrcke, because flattening him into a simple villain misses something the historical record actually supports. In 1924, he published a book with a title that says more about his real preoccupation than any plagiarism claim ever could: Die Massensuggestion der Relativitätstheorie, the mass suggestion of the theory of relativity. His argument, stripped of its more conspiratorial edges, was that the public's overwhelming embrace of Einstein after 1919 wasn't the product of careful evaluation of evidence, but of media hype, social fashion, and a kind of collective hypnosis, newspapers, celebrity, and crowd psychology substituting for rigorous scientific judgment. There's a real and even prescient worry buried in there about how science gets communicated and consumed by the public, about whether fame and truth are tracking the same thing. The trouble is that Gehrcke used that legitimate worry as cover for increasingly personal and unsupported attacks. And he never seemed to apply the same skepticism to his own motivated reasoning that he demanded of Einstein's supporters. There was likely something more personal tangled in there too, even if Gehrcke never said so outright. He had built an entire career on the values of hands-on, mechanical, visualizable physics, precision optics, measurable interference patterns, results you could point to on a photographic plate. Relativity's triumph didn't just contradict a theory he disliked, it threatened the prestige of an entire tradition of experimental physics that men like Gehrcke had devoted their working lives to. When the world's newspapers ran headlines about space-time curving starlight, nobody was writing those headlines about interferometer plates. That kind of eclipse of an entire scientific style, not just a professional rival, can sting in ways that are hard to fully separate from the more principled objections a person insists are the real motivation. Gehrcke never let the matter rest. Through the 1920s, he kept publishing pamphlets and articles rehashing the Gerber question, compiling his arguments and reprints into further editions, treating each restatement as though repetition might eventually substitute for new evidence. It never did. Physicists who actually worked through Gerber's math kept reaching the same conclusion. The formula's agreement with observation was not something that could be trusted as a genuine derivation. Some historians studying the case since have suggested Gerber may well have reasoned backward from the already known anomaly, tuning his assumptions until they produce the expected figure, precisely the kind of maneuver that can look, from a distance and decades later, uncannily like foresight, while actually being closer to a lucky, unstable fit. Then came 1933, and the ground shifted under everyone. Hitler's rise to power put men like Leonard and Johannes Stark, another Nobel laureate turned zealous ideologue, in position to weaponize Deutsche Physik as state doctrine, explicitly targeting relativity as an example of degenerate, non-German Jewish science. Einstein, who had already left Germany, was stripped of his citizenship. His property was seized, propaganda circulated attacking him personally, at one point reportedly with a bounty attached to his name in extremist literature. The old Gehrcke-Gerber affair, which had started as a technical priority dispute wrapped in genuine philosophical anxiety, got swept up into this much larger and far more sinister campaign, whether or not Gehrcke himself fully embraced where it had gone. Historians who have studied his later writings and correspondence, notably Milena Wayzek, in her detailed study of Einstein's public opponents, note that Gehrcke maintained to the end that his objections were scientific and methodological, not racial, a claim that deserves to be recorded honestly rather than erased, but also one that historians have treated with considerable skepticism given exactly whose company he kept and exactly what his years of campaigning had made politically useful for others. Gehrcke himself kept his post at the renamed Physikalisch-Technische Reichsanstalt through the Nazi period, retiring in 1936, and lived until 1960, long enough to see relativity become one of the most thoroughly confirmed theories in the history of physics, and Einstein become arguably the most famous scientist who ever lived. His own scientific contributions, the interferometer work, his spectroscopy, didn't vanish. They're still cited in the history of optical instrumentation. But his name today is inseparable from the plagiarism campaign, a strange kind of legacy, split down the middle, a competent, even skilled experimental physicist on one ledger, and on the other, a man who spent decades trying to convince the world that its most brilliant theorist was a fraud, based on evidence that never actually held up. For Einstein, the affair left a mark that his public wit didn't always show. He could be devastatingly sharp in print. The Tilt Company jab was calculated to humiliate, but in private letters to friends and colleagues, he acknowledged feeling genuinely unsettled by the anti-Semitic undertones creeping into attacks on his work, undertones that would only grow louder and more organized as the decade went on. He mostly chose to respond with public composure and irony rather than sustained argument, partly because he recognized correctly that engaging too seriously with Gehrcke's specific claims risked dignifying them, and partly because he had a genuine talent for turning mockery into a weapon of its own. Modern historians of science, digging back through pamphlets, letters, and newspaper archives, have reconstructed the Gehrcke affair not as a footnote, but as a genuinely revealing case study, an early, almost textbook example of how legitimate scientific caution, wounded professional pride, media spectacle, and political ideology can all fuse together into something that looks, from a distance, like a single coherent grievance, when it's really several different grievances riding on each other's momentum. And the ghost of that old campaign hasn't fully gone away. Even now, corners of the internet devoted to casting doubt on relativity occasionally dust off Paul Gerber's name and Gehrcke's century-old arguments, recycling them as though they were freshly damning rather than thoroughly examined and found wanting by physicists who worked through the actual mathematics generations ago. What the whole episode leaves behind, in the end, isn't really a verdict about Einstein's honesty. That question was settled by the absence of any evidence he ever saw Gerber's paper, and by the fact that Gerber's derivation didn't logically produce its own famous number in the first place. What it leaves behind is a portrait of how easily a serious scientist's real defensible worries about hype substituting for proof, about abstraction, outrunning intuition, about credit and priority in a fast-moving field, can calcify into something far less honest than the concerns that started it, especially once wounded pride, public spectacle, and the darker political currents of the moment start pulling in the same direction. Gehrcke never produced the smoking gun he spent decades chasing because it didn't exist. What he produced instead was a case study in how a real scientist, working from a real laboratory with real instruments, can still lose his way entirely once the target becomes more important than the evidence.